In this video, we're going to be looking at periodic functions. So, a periodic function is some sort of function that indefinitely just repeats itself again and again and again. So, it might just look like wavy lines, but this is actually a function that is repeating itself. So let's say from here, or let's look at this right here to here. This part is the same as this part right here. Let's say I drew it exactly the same and not all messed up. So when you have a function like this that keeps on repeating itself, this is a periodic functions, and there's so many different types of them that we can look at, and we're going to look at. But first, let's look at some of the properties. So first, a periodic function. What is that? By definition, textbook is a function whose graph repeats itself on a regular interval. The y values will show you a repetitive pattern when the x values change by the same amount, meaning the height here, or the y values, will be the same repetition after a certain amount of x. So by definition, we're just repeating ourselves again and again and again and again. So one thing we need to define or learn is what is the period when we are talking about a function. So a period can also be remembered by the word cycle. So from here to here we saw that's one period. That is one cycle, and then that is another one. So these are each one period each. So if you're ever asked what is the period of this, and this goes, say this is x equals 1, and this is x equals 5, you know that the next one ends at, if the difference is 4, then the next one should be 9. The period will be the same as it repeats itself. So let's look at another thing. There's another word we have to remember. Draw. And basically, well, this goes hand in hand with peak. So peak is self-explanatory. It's the peak, the highest point. Draw is the exact opposite. The lowest point. What else do we have? Let's do something called the equation of the axis. So the equation of the axis in this case is the x-axis. Basically, it's asking, one quick way to find out is take the peak, add it to the draw, and divide it by 2. And there you have the draw. The equation of an axis. So that in this case it'll be x equals 0. Because I drew it centering it on the x-axis. Sometimes you might have a little up or a little bit lower. Another one that you have to do or remember is amplitude. drew a line through this, and let's say the peak is at 10 and the draw is at -10, our axis is 0. So our amplitude is going to be this. It should be 10 on both sides. So I guess this was a pretty much a very simple introduction to periodic functions. I guess it's going to be shorter than the other videos that we usually do. In the future or the next upcoming videos, we're going to actually take some examples and look at the sinusoidal wave, or well, there's something called the sine. Well, when we did our trigonometry section, we learned about sine, cos, and tan, and they each have their own wave, and also their inverse functions, which are actually, if you write it out, it's the CSC wave. CSC cosine, I forget what the other one is called. We have a cotan wave. And we had one more, our cosine. Oh, the name eludes me right now. I'll remember it when I remember it. Oh, sorry. Our sec function. Yes. So we're going to have all these waves that we're going to draw out and we're going to play with. And we'll actually even plug them into like real world scenarios on when we use these waves. Particularly if you go into physics or any physics related areas, you're going to be seeing a lot of wave functions, so that is going to be really fun. But yeah, I think that should